Okay, gang, let's try 45. Again, a lot of times it's perspective that confuses people. This square is not on the secant. It's not two secants. It's two of these. Two of these. So it's two of the insides. All right? So the secant is to the power 1. All right? So this is not the secant. All right, let's look at how many layers you have. The first layer is the secant. And inside the secant, they're doing some complicated things. They're first squaring the inside of the secant. So that's the second thing. And then this is the third thing. So let me write a simpler example of this, because some people may have trouble seeing this. So if I say secant x, all right, that would be like the first level. Now, I could take the x and put something with it, right? So now I've made it a composite. So now it's two layers. This is the outside, this is the inside. But then I could go ahead and do something to the inside. I could say, well, I'm going to take that inside and I'm going to square it. All right? So notice I'm not squaring the secant. If I wanted to square the secant, I'd put it here. I'm squaring the insides. So now I've made 3 layers. I have an inside, I've squared the inside, and then I have the outside. All right, so this is actually 3 layers. This is a similar version to this, what I just made up, but very similar. All right, so let's go through it. It's strictly chain. There's no product, there's no quotient, there's only one variable here, so it's strictly chain. All right, so the outer layer is the secant, so derivative of secant is secant tan. Now, this is all the outer layer. This is all level 1. What makes this difficult is that when you do secant tan, it has to be secant tan of whatever the guts are. And these are the guts. This guts in this one are huge, right? So it's secant tan of those insides. Don't lose the 3 in the front. So this is all the derivative of the outer layer. So now in your head, I want you to pretend that this is gone. Not this, because this wasn't the outside layer. Just this. All right, now I'm going to take the derivative of the 2. So the 2 comes down in front. Don't change the any. I'm not going to put a 1 here because that looks like prime in calculus. All right, so I'm not going to do that. But that's bringing down the 2, making this a 1. So now the middle layer is gone. Now I'm left with this. So derivative of this is pi. Derivative of constant is 0. So this is the derivative of the function. I know this is very challenging, but if you keep at it, you'll get it. You'll see it. Part of it is just like perspective, how to look at it. All right, so now let me combine all the outsides. Now, what I mean by outsides are things that are not inside a trig function. So I can't touch any of this. I can't touch any of this, but I can touch this, 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 and this. All right, so 3 times 2 is 6. All right, I'm going to say 6 pi. 3 times 2 times pi is 6 pi. Then I'm going to pull this guy to the front, and then I'm going to leave this guy. I need to fit a little square over there. I hope you guys can see it. This is minus 1 squared. This thing over here. All right, gang. That is the final answer. All right, we're getting into really weirdo territory. These answers can look weird. Don't assume you did it wrong because the answer looks weird. You're taking calculus. This is a high-level math course. So some of the answers at times will look bizarre, but you've done it right. As long as you follow the rules, you're good. All right, gang, that's it for this one. I'm not going to use any kind of identity or anything. We'll just leave it like that. Catch you. Bye-bye.